Have you ever sat in on a project meeting where everyone in the room has their own answers and opinions on which wireless technology to use? Then this episode is for you. And also, we share your pain. Because wireless decisions usually go wrong for one very simple reason. Teams start by asking which technology is best, when the real question is, what does the product actually need to do? Does it need to talk to a phone? Does it need to reach the cloud from a basement, a farm, or even a moving vehicle? Does it need to move a lot of data or only a few sensor values every now and then? Does it need to run for years on end on a battery? And does it need to talk to your devices only or to a public network that already exists? And that's where the confusion starts. Wi-Fi sounds familiar, Bluetooth feels convenient, cellular sounds really powerful, and proprietary radio sounds maybe a little too specialized. But none of those labels tells you whether a technology is right for the application. And once a team chooses the wrong one, the pain shows up everywhere. Power budget, certification, range, firmware complexity, installation cost, user experience, and eventually, schedule. You are listening to Würth Elektronik's What's Up Radio podcast, where we're seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Würth Elektronics specialists. We're going to shine a light on interesting topics, such as energy harvesting, wireless and radio modules, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be, with Würth Elektronics' What's Up podcast. In this episode, we're not going to be spotlighting one module or one protocol. We're taking a step back, and we're going to ask some more useful questions. When should you use Wi-Fi? When does Bluetooth low energy make sense? When is proprietary wireless actually the better engineering decision? And when is cellular the only answer that truly fits? So the easiest way to think about this is to stop thinking in protocol names just for a moment and start thinking in system questions. And there are quite a few questions to ask. First, who's talking to who? A sensor to a gateway, device to a smartphone, a machine directly to the cloud, or even a cluster of nodes to each other. Next, how far does the data need to travel? Is it going across a room, across a building, a city, or even across borders? Next, how much data are you moving? Is it just tiny sensor packets? Or is it service commands, audio, and firmware updates? Also, what does the power budget look like? Is this a line-powered product or something expected to survive on battery for months or even years? And then there's that business side of it. Do you want to rely on public infrastructure, or do you want it to rely on your own local network? Do you want a standard interface that plays nicely with phones and routers? Or do you want a closed communication system that's optimized just for your product and invisible to everything else? Once you frame the problem that way, the wireless decision gets much clearer. And before we go technology by technology, it's worth mentioning that development gets a lot easier when the radio module isn't just hardware. Würth Elektronik supports its radio modules with software tools intended to reduce the effort on the host MCU side. And when the ProWare is included as standard firmware, the communication functions can be configured with simple AT commands or AT commands instead of forcing you to build every control layer from scratch. So this means that you can spend less time wrestling with the wireless interface and more time building the part of the product that actually makes it your own. Let us start with Wi-Fi, because it's quite often the first thing that people think of when they hear connected product. And in the right application, Wi-Fi is absolutely the right answer. If you need high data rates, IP-based communication, straightforward integration into an existing local network, or a clean path to cloud services through a router or an access point, then Wi-Fi is very attractive. Now, it is standardized, it's widely understood, and especially useful when the product already lives in an environment with dependable network infrastructure. Wi-Fi makes the most sense when bandwidth matters. It makes sense when the device is close to an access point, when power is available or at least not painfully limited, and when the product benefits from speaking the same language as the rest of the network stack. If you're sending richer data, supporting firmware over the network, or building something that naturally belongs on the customer's local internet connection, then Wi-Fi starts to look really strong. But it's not magic. It's not the best answer just because a product is connected. If the device is buried behind walls, spread across a large site, expected to run on a tiny battery, or if it only needs to exchange a handful of bytes now and then, Wi-Fi can be more radio than you actually need it to be. And that's where engineers get into trouble. They're going to choose Wi-Fi because it feels universal. And then they discover they paid for that convenience in power consumption, coverage headaches, and infrastructure dependence. Now, if we compare that with Bluetooth Low Energy, or BLE, BLE is often at its best when the product needs a simple, standardized link to a smart device. If the user needs to commission the product, read status, tweak settings, trigger a service mode, or pull diagnostics from a phone or tablet standing nearby, BLE is incredibly practical. It's familiar, supported by mobile ecosystems, and it gives you a much cleaner surface interface than building a custom cable connection or expecting every product to join a Wi-Fi network on day one. And that is why Bluetooth is such a strong fit for setup and maintenance workflows. In many products, the phone is not the destination for all data. It's the tool. It is the commissioning interface, the service panel, the local dashboard. And BLE works very well in that role because it keeps energy requirements relatively low and it gives users an experience that they already understand. But again, Bluetooth is not the answer to every wireless problem. If your real goal is to connect machines to each other across larger distances, bridge through walls in large buildings, optimize a network around your own topology, or create communication that should stay closed to the outside world, then BLE can feel constraining. It's really excellent when the human interaction matters, but it's not always ideal when the wireless link is really a machine-to-machine infrastructure layer. And that brings us to proprietary wireless, and this is often the most misunderstood option in this conversation. Now, proprietary radio is not about choosing something obscure for the sake of it being different. It's about choosing freedom where standards don't fit. If the application needs device-to-device communication on your own terms, if you want to tune the trade-off between range, throughput, latency, network behavior, and energy use, or if you want a closed system that talks only to authorized devices in your own ecosystem, proprietary wireless could be exactly the right engineering choice. This is especially true when the product is not trying to be part of the public internet or directly paired to a customer's phone at all times. A lot of industrial, infrastructure, and medical adjacent thinking works this way. The real need is not connect to everything. The real need is connect my nodes reliably, efficiently, and securely for this application. And those are very different design goals. Another reason why proprietary wireless matters is actually flexibility. In license-free bands, you're not forced into a single public standard. And that gives you more room to optimize the correlation between data rate, range, and battery life around the actual job that the product has to do. It also gives you a way to build communication that is closed to generic smart devices. And this could be meaningful design choice when the product should stay inside its own controlled ecosystem. Inside Würth Elektronik's proprietary portfolio, that flexibility is supported by ProWare. This is an important point because proprietary radio is not just RF hardware. The real value is the operating layer that makes it usable. ProWare gives you a preloaded radio stack with simple command-based control, and it's designed so you can tailor behavior to the application rather than force the application to live inside a fixed consumer-style model. And that is why proprietary wireless can feel much more like a system tool than just another protocol checkbox. So when are you going to lean toward proprietary? Well, when you want machine-to-machine communication, when you want a closed and controlled network, when a standard protocol is either too costly, rigid, visible to outside devices, or simply not optimized for the range, throughput, or power profile that you need. And very often, when you're building infrastructure inside a product family rather than a universal consumer endpoint. So now let's move on to cellular, because cellular solves a completely different class of problem. Cellular is what you choose when the product needs to reach the cloud from where it lives, not from where the router happens to be. If the device is deployed remotely, spread across wide geographies, installed in the field, moving between locations, or if it's expected to report back without depending on local Wi-Fi or a custom gateway, cellular becomes extremely compelling. It is a licensed spectrum communication backed by network operators with standardized security and authentication models and a direct path from the device into wide area infrastructure. And that makes cellular especially powerful for remote monitoring, asset tracking, distributed infrastructure, smart city installations, metering, and any application where local network access is either unreliable or completely unavailable. The big win is not just range, it's independence. The device can exist outside the world and still participate in a managed, secure connectivity model. Within cellular IoT, or Internet of Things, it also helps to separate narrowband IoT, NB-IoT, from LTE-M, which is long-term evolution machine-type communication, a type of low-power, wide-area network radio communication technology standard. If the device mostly sends small amounts of data and it stays in place, NB-IoT can be a very sensible fit. Now, if the product needs higher data rates, lower latency, or mobility support, LTE-M usually becomes the better answer. So even inside cellular, the right choice still depends on what the system is trying to do, not just the fact that it needs long-range access. Of course, cellular also comes with its trade-offs. It's usually not the lightest option in terms of deployment complexity, operator relationships, or overall system cost. So if the product sits 5 meters away from a stable access point, cellular may be solving a problem that you don't actually have. But when the device needs to talk to the cloud from virtually anywhere, there is a reason cellular keeps winning that argument. And here's the point that I think is the most useful for these design teams. The best answer is often not one radio. It's going to be a combination of radios, each handling a different job. Bluetooth could be the local user and service interface. Proprietary radio can connect distributed sensors or nodes inside the system. Wi-Fi can provide the local IP path when building infrastructure is available. And cellular can handle remote backhaul when that infrastructure is not available or not trusted. So once you stop forcing one technology to do everything, the architecture often becomes much simpler and better. And that's a healthier way to think about wireless, not as a winner-takes-all choice, but as a stack of roles. Human interface, local machine network, site connectivity, wide area backhaul. Different technologies are good at different layers, and products become more robust when we let each one do the job that it's actually good at. So if you want a quick rule of thumb, here it is. Use Wi-Fi when you need bandwidth, IP-based communication, and a natural connection into an existing local network. Use Bluetooth low energy when the product needs an easy, standardized, short-range link to a phone, tablet, or local service interface. Use proprietary wireless when your device mainly needs to talk to each other, when flexibility matters, when a closed system is an advantage, or when you need to optimize range, throughput, and energy behavior around your own application instead of around a public standard. And use cellular when the device has to reach the cloud from the field, over wide areas, with mobility or remote deployment in the picture. So in other words, ask not what your wireless technology can do for you. Ask what you can do with your wireless technology. All right, that's not exactly how the quote goes, but it is along those lines. Basically, do not ask which wireless technology is best, because they all have their benefits and their downfalls. Ask what type of relationship your product needs to have in the world around it. With a phone, with a router, with your own devices, or with the cloud from anywhere. And once you answer that clearly, the right wireless choice usually stops being so mysterious. And that's really the takeaway from this episode. Wireless architecture is less about brand names and buzzwords and more about matching the radio to the role. And if you do that well, you can actually reduce power problems, avoid over-redesign, shorten development time, and build a product that behaves the way users and engineers both expect. To learn more about Würth Elektronik's wireless connectivity portfolio and to get more hands-on, go ahead and visit www.we-online.com and browse the Wi-Fi, Bluetooth, proprietary, and cellular solutions that are going to fit your application. And if you're still deciding, start with the system questions first. It's almost always where the right answer begins. Now, we know that while some streaming platforms are making that switch over to video format, there are still plenty of listeners tuning in through audio only. So if you want to learn more, head on over to our website. You can download data sheets and additional technical materials, find all of the images, demonstrations, and diagrams we discussed today. You are listening to Würth Elektronik's What's Up Radio podcast, where we're seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Würth Elektronik specialists. We're going to shine a light on interesting topics, such as energy harvesting, wireless and radio modules, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Elektronik's What's Up podcast.